Assalamu alaikum. My name is Khalid al from grade 12 BC, and today I'm going to give you a brief presentation on differentiations, applications, and examples. So, what is differentiation? Differentiation is a method of finding the derivative for a function at any given point. And what is the definition of the derivative? The derivative is the slope of a line that lies tangent to the curve at the specific point. So, in simpler terms, the derivative measures the steepness of the graph of a function at some particular point on the graph. Thus, the derivative is a slope. So, I have provided you here a picture that shows that derivative is the, as said before, finding the tangent of the slope. So, here is an example which is dy over dx, and just to show you a brief about differentiation. So, basic differentiation. I have given you here four basic functions, and I would like to show you how to derive some functions here. So, starting off with the first function, y equals 12. So here there is no need to rewrite anything because it is in the correct order, so I've left that box blank. So to differentiate such a function, y equals 12 is a constant, and deriving a constant, so deriving any constant, whether it be 12, 100, 2 million, any number that's a constant, the differentiation of that number of that function, or to derive that function, the answer would be 0. So in simplifying, it would still be 0 with the reason, which is that because it's a constant. The other function here, f of x equals x power 7. So there is as well no need to rewrite the function here because it is in the correct order. To differentiate such a function, what we would have to do is multiply the 7 or the power with the number before before x. So if there is no number, which means it is 1, and so 7 multiplied by 1, it is 7. So it will be 7x, and then we would have to subtract 1 from the power. So it would be 7x to the power 7 minus 1. So it would be in simplified forms, it would be 7x power 6. The next question, y equals 1 over x power 5. So for this function, we would have to rewrite it to be 1 times x power negative 5, because we cannot derive this function unless the x power 5 is on top. And so when we bring the x power 5 on top, it changes the sign of the power to x power negative 5. And to differentiate this function, we multiply the power as said before with the number before the x, which is 1. So minus 5 multiplied by 1, it is minus 5. And it will be, we subtract 1 from the power. And so it will be minus 5x power minus 6, because minus 5 minus 1, it is minus 6. So to simplify this function, we would need the power to be in positive form, and so we bring it back down to be positive, and the answer is minus 5 over x power 6. The next question here, which is f of x equals the square root of x. So we'd have to rewrite this function, and to rewrite it, we'd have to know that in a square root, to rewrite it, we take what's inside x and we write it as it is, and then we take the power which is on x. The power on x here is 1, and that's the power inside the square root, and the power outside is 2. So what we'd have to do to write the power is we write in over out. So the power in is 1 and the out is 2, so it would be x power 1 over 2. To differentiate this function, as said before, we multiply the power half by the number before x, which is 1. So 1 times half, it would be half times x power, and then we would subtract 1 from the power. So the power here was half, so half minus 1, the answer is negative half. So it would be half x power negative half. As said before, we don't want this power in negative form, and so we bring it down to the correct, so it becomes in the correct shape or order or form, and so it becomes half over x power half. So here are some real-life applications of differentiation. We have several applications, and I have listed a few. Number 1, which is the tangents and normals. Number 2, Newton's method, specifically to be in Newton's method interactive graph. Number 3, which is the curvilinear motion. Number 4, which are related rates. Number 5, curve sketching using differentiation. And number 6, which are the applied maximum and minimum problems. Number 7, radius of curvature. And the one that I'm going to give you a presentation about, or a brief explanation or further explanation in, which is the finding the acceleration due to gravity. Here are some pictures to show you about the applications of differentiation. So, finding acceleration due to gravity. Here is the example of the moon. Because the moon has no atmosphere, a falling object on the moon encounters no air resistance. In 1971, astronaut David Scott demonstrated that a feather and a hammer fall at the same rate on the moon, and so the position function for each of these falling objects is given by St equals negative 0.8 t squared plus 2, where t is the height in meters and t is the time in seconds. What is the ratio of Earth's gravitational force to the moon's? So to solve such a question, first we would have to get the acceleration, and to find the acceleration we would have to differentiate the position function twice. So what is the position function? The position function here is St equals negative 0.8 t squared plus 2, and to derive this function, as said before, we would have to multiply the power by the number before t, which is 2 multiply negative 0.81, and we would get negative 1.62 t, and then we would have to subtract 1 from the power, so it will be negative 0.81 t. It would be negative 1.62 t. And then the positive 2, the number 2 here is a constant, and so it cancels. So we'd get the velocity function first, which is negative 1.62 t, and to get the acceleration function we would have to derive the velocity function, and so we would have to write s prime prime t, because first of all, as shown before, in the position function we derived it first of all the first time to get the velocity function, so it becomes s prime t equals negative 1.62 t, and to get the acceleration function we derive it again, and we get s prime prime t equals negative 1.62, and how we get this answer is that the power on t is 1. As I said before, if there is no power, that means it is 1, and so we multiply 1 by negative 1.62 and we get negative 1.62, and then we subtract 1 from the power, and so 1 minus 1 is 0, and so t is cancelled. Now I would like to explain briefly about the moon, just give you some information to continue solving this question. So the moon has a mass of 7.349 times 10 to the power of 22 kilos, and the earth has a mass of 5.976 times 10 to the power of 24 kilos. The moon's radius is 1,737 kilometers, and the earth's radius is 6,378 kilometers. Because the gravitational force on the surface of the planet is directly proportional to its mass and inversely proportional to the square of its radius, the ratio of the gravitational force on Earth to the gravitational force on the moon is, what we'd have to do is we have to get the Earth's mass, which is 5.976 times 10 to the power of 24, 5.976 times 10 to the power of 24, divided by the Earth's radius, which is 6,378 kilometers, but it would have to be squared here. So the Earth's radius would be squared because it is inversely proportional to the square of its radius. So 6,378 squared over the moon's mass, which is 7.349 times 10 to the power of 22 kilos, divided by 1,737, which is the moon's radius, squared as well, because it is as well inversely proportional to the square of its radius. And so the acceleration due to gravity on the moon is negative 1.62, as we got it before here on top, as you can see the acceleration function. So it is negative 1.62 meter. Acceleration due to gravity on the moon is negative 1.62, as we got it before here on top, as you can see the acceleration function. So it is negative 1.62 meters per second. So because the acceleration due to gravity on Earth is negative 9.81 meters per second, which means meters per second squared, the ratio of Earth's gravitational force to the moon's is Earth's gravitational force divided by the moon's gravitational force, which is negative 9.81 over negative 1.62. And then we would get a rounded up answer, which is 6. Thank you.